Okay guys, this is the Unit 2 study guide video for AP Statistics. This is a new one. If you were using the old practice test and using that old video, totally fine, it's good extra practice, but this is going to be the more up-to-date, more relevant one. If you did that other one, you're better prepared. But please do this one. Focus on this practice test. Okay, so just a quick review. Test for my class is Friday. If you're Turks, it's going to be on the following Monday. Pencils, scientific calculator allowed, toolkit only. Just to remind you that like only the toolkit, not open binder, just the toolkit. So that's the packet, right? The toolkit packet. All the resources are here, including the toolkit key. So if you need the key for the toolkit, go here. It's on here. Okay. You got to submit your delta by 9:30 on the day of the test. Okay. So you're not gonna have time afterwards. Get it done by 9:30 on the day of the test. This is just like a checklist of things that you should do. And it'll be a majority of the video here. Okay, let's get started. The graph below shows education measured in years versus income in dollars. We have a regression equation here. We have our R-squared value. Let me highlight that line going through here. So we're going to fill in the sentence frames based on our slope. So reminder, really important that you are able to identify the slope from the regression equation. Remember this y hat, that's the prediction. This value here is the slope, and this value here is the y-intercept. Remember the value next to the x is the slope. Okay, so when we fill out the explanation for slope, our x variable here is education measured in years. So when years of education, let me zoom in a little bit here. When years of education increase by 1, income in dollars increases by my slope, 2,297. 2,297. Okay. Let me zoom out a little bit here. Sorry, I'm just gonna get this. There we go. Okay. Y-intercept. When my x variable, it's years of education, equals 0, my y variable, income in dollars, equals my y-intercept. My y-intercept is 25,887. 25,887. So this means if I have no years of education, this is like the income that I would be predicted to make. Okay. R squared. So my R squared value is 0.258 as a percentage. That's 25.8%. Remember, like if you multiply that by 100, that gets you the percentage. So this means 25.8% of the variation in income is explained by the variation in education. Okay. So these are the sentence frames that you need for the test. Like there are variations of these that are okay, but you need to know these. Okay. So that's what we're going to practice first. Sentence frames activities. So, get in the habit when you read a problem, get in the habit of identifying y-intercept, slope, and R squared, and being able to write the sentence. That's what we're going to practice here. And you can use this sheet for reference, right? So, but as you go on, try to like look at them as little as possible. Try to really know it. Okay. So my y-intercept, let's start by just identifying y-intercept. This is my y-intercept right here. It's my y-int. That 7 is my slope. And then obviously the R squared is right here. Okay, so my y-intercept means, now we need to know what the x and the y variable are. I'm going to label them down here below. X is temperature in degrees, y is number of ice creams sold. Okay, so for y-intercept is when my x is 0, so when temperature, right, that's my x variable, is 0, the y value is
Fernando Mendez, Fernando Mendez.
Sorry about that, guys. When the temperature is 0, the y value is the number of ice creams sold. My bad. The number of ice creams sold is 3. That's the sentence frame. Slope. My slope is 7, so I say for when temperature increases by 1, ice creams sold increases by 7, and then r squared. So when you make that a percentage, 73.2% of variation in ice cream sold is explained by temperature. Okay. Let's do like another one for practice, but you guys, I think you're getting the gist of it. Okay, let's go like to 3. Let's do number 3 as an example. This time r squared is first, so make sure to make it a percentage. 11.8%. Now let's identify what x and what x is number of minutes played in the NBA season, and then y is number of points scored per season. So 11.8% of variation of points scored is explained by minutes played. Okay, that would be the r squared. The slope, my slope is 0.63. As minutes played increases by 1, points scored increases by 0.63. And then last one, y-intercept. When minutes played is 0, points scored is -16. Get the gist of it? So all you're doing is using these sentence frames and then replacing x variable, y variable, y variable, x variable, y variable, slope, and so on. So as long as you have these in your notes, make sure these are in your toolkit so you can use them. You will be fine. Just understand that you need to identify what these are and be able to identify slope and y-intercept from the question. Sometimes, in this case, when minutes played is 0 points scored is -16. This doesn't make any sense because you cannot have negative points, right? So also be able to understand it in the context of the question. Okay. All right, we're gonna keep going. This scatter plot shows the amount of chocolate consumed per person and Nobel Prize winners for various countries. What's the explanatory and what's the response? So you need to know explanatory is always on the x and response is always on the y. So what's response? So that means explanatory is chocolate consumption. Chalk consumption. And then response is Nobel Prize winners. Prize winners per 10 million. Nobel Prize winners. That's fine. I would accept that. That's fine. The strength. Well, you're looking at this. We're looking at the scatter plot here and estimating the strength, direction, the form. So as I look at this, the form is linear. It looks like there is some sort of linear relationship. I know it gets more spread out over here, but in general, it's like more or less a straight line. So that's linear. The direction is positive because it's going up. And the strength, you look at the points and you can make an estimation. Like they're very closely associated here, and they're like more weak up here. So I'm gonna kind of average, like this area might be like pretty high, like maybe like a 0.9 R value. And then as you get further out, it gets more spread out. So let's call it like moderate strength. And there's some, as long as you're in the right ballpark, that's fine. This is moderate strength. Is there causation? Why or why not? So let's think about what we're measuring here. We've got chocolate consumption and Nobel Prize winners. Does chocolate consumption mean you win more Nobel Prizes? No, that's not causation. No. Or not necessarily, because chocolate consumption doesn't relate to Nobel Prizes. If it was maybe like science funding was your explanatory and Nobel Prizes was your response, then yeah, there was a relationship. That could be causation. But if the variables like don't make sense or not related, there's no causation. All right, for each, we're matching the plot to the R value. So remember that the R value goes from -1 to 1, and like the closer it is to 1 or -1, the more correlation it is, or the stronger the linear correlation. So I actually think B is kind of easy to do first because there's clearly like no correlation here, so I want something close to 0. This indicates close to 0, and when I look at my options, one close to 0, that's 0.22. And then I've got two that are negative here, like they're going down. These are negative, right? This is down, and one's positive. So that makes it easy because the positive one has to be the positive number, so that's got to be D here. And then I've got like a stronger negative and then a weaker negative. The stronger negative is going to be closer to -1. The weaker -1 is going to be closer to 0. So the stronger negative, that's A, must be -0.74, and the weaker negative would be C. Okay. Plug in and solve to find each of the following predicted values. We have, these are the same equations as before. Y is the number of ice creams sold, and X is the temperature in degrees. How many ice creams will be sold on a 53-degree day? I just want to remind you that these are predictions, right? We're predicting this. This isn't actual, this isn't reality, but we're predicting. So when we put a 53 in, 53-degree day, remember X is temperature. So what means in the formula, Y hat equals 3 plus 7 times 53. So 7 times 53 in the calculator, that is 371. So I have 3 plus 371, which is 374. So 374 will be sold. Ice cream. Okay. Really show your work, guys. Write down the formula. Don't just do it in your head. Write down the formula. Show me your work. Okay. Next one. So it's a coffee one. How many mistakes does he make on 1.2 cups of coffee? So let's write out the equation. Y hat equals 8 minus, so X is coffee and Y is mistakes. So if I have 1.2 cups of coffee, that's going to replace the X here. So we can do 1.3 times 1.2, again in the calculator. 1.3 times 1.2, 8 minus, that's 1.56, 8 minus 1.56 is, in the calculator, 6.44. So 6.44 mistakes are predicted. Okay. Y hat equals negative 16 plus 0.63x, where x is the number of minutes played. How many points will someone score if they play 215 minutes? So it's the same stuff, guys. X is minutes played. So if it's 215 minutes, that means I replace that x with 215. So we're gonna have y hat equals negative 16 plus 0.63 times 215 in the calculator. 0.63 times 215 is 135.45. Negative 16 plus this. So guys, be careful. You're not adding 16, it's negative 16. So in the calculator, negative 16 plus 135.45, 119.45 points.
The audio still at us.
Okay. All right, we're moving on. Last page here. You guys get the gist of this, right? So these are going to be the same, right? Y is the height, X is the water, how high will the plant be if it's 11? Why don't you try this before I do it? Okay, so I'm gonna do it now. Y hat equals negative 23 plus 4.6 times 11. Same thing. Multiply it out. 4.6 times 11. It gets to be 27.6. So that would be inches. All right. X is followers. Y is daily screen time. How much screen time will they have as 324 followers? Same thing. Y hat equals 0.2 plus 0.03, 324. Same thing. 0.03 times 324 plus 0.2 is 9.92 hours. Okay. Use the equation for number 5, but go the way. How many Instagram followers would would give someone an expected screen time of 5 hours a day? So here they're doing a switch. They're saying that the Y, the screen time is going to be 5. So 5 equals 0.2 plus 0.03x. So in this case, you're actually going the other way. And so in this case, we're trying to get x alone. We're going to subtract 0.2, subtract 0.2. It's going to get us 4.8 equals 0.03x. Then we're going to divide by 0.03, divide by 0.03, and 4.8 divided by 0.03 is 160. So 160 followers would mean 5 hours. So this is the opposite way. So make sure you know, okay, am I plugging in the x or am I plugging in the y? If it's the x, it just goes in here. If it's the y, you go the other way and you solve for x. Okay, we're on the last question. Residuals and residual plot. So this is like what we did last class on the quiz. The following data comes from a correlation regression line where x is the temperature and y is the number of ice cream sold. Predict the ice cream sold for each temperature, then calculate the residuals. So to find the predictions, all you're doing is taking the temperature and plugging it in to the equation. So I recommend doing this like on scratch paper, but I'm going to do it on the calculator here. So what I'm doing here is like 40 times 2, that's for the first one, plus 5. So that'll be 85. So that's my prediction here, and I'm going to keep going. 65 times 2 plus 5, that's 135. 72 times 2 plus 5 is 149. That's a 5, by the way. Just make sure that's clear. It's a 5. This is 149. 79 times 2 plus 5 is 163. 87 times 2 plus 5 is 179. And then 103 times 2 plus 5 is 211. So predictions, just plug in the x value. I would like label this over here. This is the x and this is the y. So like then you know, oh, okay, I'm plugging that into that. Once you identify the x is temperature, then you know, okay, I'm plugging that in. But make sure you define that. Residual is actual minus predicted. So it's really important to know that in your notes 100%. This residual is actual minus predicted. So all I'm doing here is this minus this, this minus this, this minus this, this minus this, and so on. So let's do that. 68 minus 85, negative 17. 147 minus 135, 12. 140 minus 149, negative 9. 174 minus 163, 11. 87 minus 163 minus 179. 179 is negative 16. And then 219 minus 211 is 8. That's one done. We made our predictions by plugging it in, then we subtracted to find the residuals. Make your residual plot. So now, this right here is my temperature, which is up above, and then my residuals are right here. So at 40, my residual is negative 17, so it's going to be down like roughly here. At 65, which is like right here, my residual was 12, so it's going to be like roughly like here. At 72, it was negative 9, 72 here. At 79, it was 11. At 87, it was negative 16. Roughly there. And then at 103, which is up here, it was 8. So that's the residual plot. You just find the x values here, and then you plot the residual there. So is this good? Yes, it's good because there is no clear pattern. If there is a clear pattern, like a U kind of shape, parabola, you don't connect the dots, by the way. Like you don't want to connect those. So you're looking for like the shape of it. I can show an example of like a good and bad one just while I'm here. So remember good ones, it's like even on both sides, like kind of no pattern, something like this. This is good. A bad one might look like this, like a lot up here, then a lot down here, and then a lot up here. So this is bad because that's just showing like that pattern, like a lot of under predictions, then a lot of over predictions, and a lot of under predictions. That's like not good. You want it to be even on both. Back to here. A last question. Suppose we had the following regression equations for exponential quadratic metals. Use them to predict the ice cream sold in a 72-degree day. So this is what we did a couple classes ago when it came to the regression models. Once you get to here, okay, we're on a 72-degree day, so we're going to plug in 72 in for x here and a 72 in here. So let's start by doing that. So 0.008 times 72, that's 0.576 plus 1.59. I have log y equals 2.166. And then here, same thing, 0.098 times 72 plus 4.85 is 11.906 equals root y. So we're not unfortunately done here because we want y alone, we have to undo the log. To undo the log, you erase it, you do 10 to the power of each side, 10 to the power of this and 10 to the power of that. That cancels the log, so we just have y now. And here on the calculator, I'm just doing 10 then the caret right here, caret 2.166, and I got 146.55. Okay, and then here, so that's my prediction. Here, to get rid of that root, I got to square both sides. So that will undo that square root. So then 11.9 squared is 141, or I'll do the whole thing. 11.906 squared, it's under here. Oops, 11.906 squared, 141.75. Okay, so these are the key parts. Make sure you're familiar with r squared and the slope and the y-intercept. Make sure you know what they mean. Make sure you get the toolkit notes from online. All right, good luck.